Assembly lines and stations are designed for manual operation, as fully automatic or in a combination of both. Individual stations can either be connected by a conveyor system or the parts may be handled manually. The assembly lines are designed according to customer requirements using optional arrangement. The assembly stations used in the lines or as standalone are manufactured to the highest standard of the European automotive industry. Depending on demand, they may be provided with various accessories, for example with polka yoke systems, identification of exchangeable tools, and identification systems. The lines can be controlled using a central control system or decentralized control systems for individual stations. We usually use Siemens control systems. The stations are mostly interconnected with high-frequency data bus lines for the assembly process operation and control and for the process data collection. The data obtained during the assembly can be collected and archived. It includes the results of press operations, data from tightening equipment, data from measuring and monitoring operations, and manufacturing statistics. The data is stored on the server disk or sent to the superior control system. The data can be statistically processed and the results stored in databases. The processes are visualized on a display. We'll use the EGR valve to show you an example of the assembly line that's designed to provide a full assembly and testing of the component. Before entering the assembly process, each part is provided with a holder with an identification chip. This chip ensures the identification of components during the whole assembly process. The applicator applies the adhesive into the valve body opening. The adhesive is dosed accurately. Pressing of the cooling circuit tubes, including the check of the pressing process parameters, follows. The tube is positioned precisely towards the body. The bearings and rubber sealing are pressed. The pressing parameters are monitored and evaluated again. After the assembly, the pressed sealing is secured in position. In order to do that, the edge of the valve body is caulked at several points using a special caulking head. The partially assembled valve is inserted into the transport pallet together with other components to be welded. The pallet is transferred to a turntable where the welding takes place. The position of all components is taken precisely by a digital camera before welding. The result of measuring gives the coordinates for the position of welds. The welds are checked by the camera after welding. The pallet with welded components is transported back and the valve is returned to the line. On the station located next to the main line, the holders and controllers are pre-assembled. The correct process performance is controlled by reaching the end position of the pressing unit. The sealing ring and the connecting tube are assembled manually. The screws of the connecting tube are prepared automatically. Both screws are retightened at the same time. The assembly on the pallet is rotated into the vertical position. The sealing and the cooler are inserted. The screws for tightening of the cooler are prepared automatically. The tightening process for all screws is carried out synchronously. Due to the rib on the valve body, which restricts the access to the screw, one atypically located oblique tightening spindle was required. The holder for the installation into the engine is fit to the body in an exactly defined position. Due to the risk of damage of valve electronics, this station, as well as the following one, is designed as anti-static. The tightening of screws is the last assembly operation. It's followed by the sorting station where the non-conforming components are sorted out to the side branch of the line, where the components are removed from the pallet and rejected or repaired. The completely assembled unit is tested. The connecting dimensions for the installation into the engine as well as the functioning of the whole assembly, are tested gradually. The measured values include tightness of the water port, tightness of the internal space of the valve, and airflow with the flap opened and closed. In the case of non-conforming test results, the non-conforming component is transported to the secondary branch of the line. The assembled and tested units are marked by a laser. Each piece is provided with a unique identification number that enables matching each part with the stored data set obtained during the assembly. The finished part is taken off the pallet and packed, and the pallets on the circulating conveyor continue to the beginning of the line. The gantry loader is